Welcome. Today we are going to solve for area of polygons. We will be addressing 6th grade content Common Core standards in geometry that say that we will be able to apply formulas and procedures for area of plane figures. And we can identify the area of right triangles and other triangles and special quadrilaterals and polygons by composing into rectangles or decomposing into triangles and other shapes. And we will apply these techniques in the context of solving real-world and mathematical problems. Okay, we will be using critical thinking and problem-solving skills, and we will be using multiple processes and diverse perspectives to explore alternative solutions to problems. We will begin with our basic shape, which is the rectangle, which has two pairs of parallel sides and right angles. Okay. And to measure the area of any figure, okay, we could count the squares because area means that you're counting all the square units that fill in the inside of the shape. So here we could count the units and that would work just fine. Okay. But not all shapes are that easy to count. Sometimes they're much bigger and sometimes they don't show the little squares. So we need to have another way of doing that. So we use formulas. Okay. So we use the dimensions of the figures. In this case, we have the base of the rectangle and the height, okay, also called the length and the width. So the size can also be called base for the length and height for the width. So to find the area of a rectangle, we would be multiplying the base times the height. So the formula would be area equals base times height. For this particular rectangle, we'll give it some measurements here. So we would determine the area of the rectangle by replacing the variables. Area equals base times height. And we would replace the variables into the formula. So if our base is 8, we replace the b with 8. Since our height is 4, we replace the h with 4. We multiply to solve. 8 times 4 is 32. So the area of this rectangle is 32 squared inches. Okay. You may want to pause the video for a moment and write down your formula. Give yourself an example. You will be needing it throughout the unit. Our next figure is the triangle. It has 3 sides. Okay. This particular triangle is a right angle. It has a right angle, so it's a right triangle. And to find the area of this triangle, we could try to count little squares, and we could do that by cutting this rectangle in half using a diagonal. We could try counting squares, except that these squares got cut off. So we'd have to piece them together, and that's not very practical. So to find a formula for triangles, we're going to take half of the formula that we use for the rectangle. So to find, okay, why? Because by cutting that rectangle in half, we have 2 equal triangles. And if my program worked the way I wanted it to, I could flip this triangle over and show you that it fits right in there. But I can't. Okay, so we have some dimensions here. Okay, we still have the base and we still have the height, but we only have half a rectangle. So the formula to find the area of a triangle is 1/2 the base times height of the rectangle. So we have 1/2, our base is 8, our height is 4. So we multiply the 8 times 4, which is 32. We take half of that, which is 16. And if you recall, the area of our rectangle was 32. Half of that is 16. take a moment to write down your formula, and you may want to draw this diagram to remind you why this formula is half. Okay, so if you don't have a right triangle, okay, we call the others irregular triangles. Okay, you would solve the same way. Okay, so you draw an imaginary height line here, which is going to be a line that's perpendicular to the base. Okay, that means it forms a right angle here. So this is your height. You're going to use the same formula for any triangle, which is half the base times the height. And just make sure that when you take the base, you start at one vertice and take it all the way to the other vertice. Okay, do not cut this at the imaginary height line. Okay. Replace your variables, same as before, and solve. The area of this triangle is 16 squared inches. Okay, you can stop at any time to jot down notes in your journal. Okay, our next figure is a parallelogram, and we are going to go back to that rectangle as our reference point. And what we're going to do to this rectangle to create a parallelogram is cut a triangle off of one side, and we are going to take that triangular piece and we are going to slide it over across to the other side, which creates a nice little parallelogram. And what's the difference between a rectangle and a parallelogram? The angles. A parallelogram has no right angles. What we created here is that imaginary line because in order to find the area, we need to have a height, so it kind of refers back to our rectangle. So as you can tell, it's the same amount of area that we had with the rectangle. So to find the area of a parallelogram, you're going to use the same formula that you did for the area of a rectangle, which is area equals base times height. So in this example, to find the area, you're going to replace your variables as you did before. And again, your base is the actual shape from one vertice to the other. Do not count the imaginary line. Okay. Replace your variables as before and solve. And that's how you find the area of a parallelogram. Okay. Now we're going to take that parallelogram for our last shape here, which is the trapezoid. And by cutting that parallelogram in half, okay, we are creating two trapezoids. How do we know we have a trapezoid or two trapezoids? Because they have one pair of parallel sides only. Okay, and that's the criteria for a trapezoid, one pair of parallel sides. So to find the area of that trapezoid, and again, if you flip this over here, you see that you have two equal shapes, which means we have half of a trapezoid. So we're going to use half of the formula of a trapezoid. By doing that, we have cut the base of the trapezoid. So we say this segment here up to the cut line is base 1, and this segment is base 2. And if I were able to flip my little figure this way, you would see that this is the same length as this base 2 here. So to use our formula, we are going to take 1/2 of the parallelogram. So we add the base 1 and base 2 and multiply it by the height. So let's give it some numbers here. So our base 1 is 3, our base 2 is 5, and our height is 4. So we replace our variables. Base 1 is 3, base 2 is 5, height is 4. Okay, we saw parentheses first, same as always. 3 plus 5 is 8, multiplied by 4, and we're taking half of that. 8 times 4 is 32, divided by 2 is 16. The area of this trapezoid is 16 square inches, which is half of what the entire parallelogram was, which is the same as what the rectangle was. Okay, so this is your fun formula. So why do we need to know all these formulas? Because you're not always going to get a rectangle or a triangle or a parallelogram. Sometimes you're going to get more interesting figures. Okay? So we use the geometric formulas to find the area of other polygons. For example, okay, and this is where the decomposing part comes in. We've done some of that, but you can take a figure and determine what shapes you see within that figure. So this one here, for example, okay, what figures do you see here? Okay. Different ways that this can be decomposed. I'm going to add a line right here. And so now you see that we have one rectangle here and another rectangle here. So to find the area of the entire figure, we're going to add this area and this area. Okay. And then you will have the area of the entire polygon. So it might look something like this. Give it some measurements. So we have area of a rectangle plus area of a rectangle. Replace the variables. Okay, so here we have a base times a height, 4 and 6. And for the second rectangle, the base and the height, 8 times 4. Solve parentheses and add. So this figure has an area of 56 square units. Okay, let's try another one. Okay, what figures do you see here that would be helpful for solving? Because we do not have a formula for that. Okay, we can try this. So now you have two parallelograms, and of course we have a formula for area of a parallelogram. Let's give it some numbers. Okay, so we have two of the same parallelograms. So our formula for one is base times height. Okay. Replace your variables and solve. With 78. Multiply that by 2. Would be 156. I think I forgot a number. Okay. And we'll try one final figure. This pentagon with equal sides. So how can you decompose this? Okay. We can try this. So now you have a triangle and a trapezoid. So find their areas. There's your area of a triangle and a trapezoid. And you can replace your variables to find the area of the pentagon. Okay, so now you get to apply these techniques in the context of solving real-world mathematical problems. Follow the link to get your assignment. You can always refer back to this video and your notes as needed. And good luck. Have some fun with your formulas.